Hello everyone. Thank you for joining us for the webinar today, and we hope that you're all staying safe and healthy. My name is Lotta Kågström, and I'm working as Marketing Manager for Screening Solutions. Today, our webinar topic for you is 3 ways to improve your screening process with media. And I know that we will show some real cases to explain the most common pitfalls and how you can avoid them. It's now the designated time, and we will begin the webinar. So next slide. This webinar is part of Metso's new Packed with Performance webinar series. We started this series as a way to stay connected and share know-how in a time when it's been more difficult than ever to meet with customers. The webinar are for all customers, and we have a variety of topics to hopefully address both technical and a business audience. And today it's more of a technical topic. The overall aim is to help you perform to your best. We hope that you will enjoy and find the information from our experts useful. And next slide. Before we get into the topic, just a few housekeeping notes. First off, the webinar is scheduled for 45 minutes. And after this intro, the main presentation should take about 30 minutes. And after that, we have time for some questions. You should know that the webinar will be recorded. And during the webinar, you can always use the question box. We will then try to answer all the questions after the webinar. But if there's any few questions that we don't have time to answer, we will do it by email afterwards. And the recording, it will also be distributed by email. Just a little required legal disclaimer. This webinar is intended as information only. It's not a claim and it's not a commitment. And some products or services may not be available in all countries, but you can always check with your local Metso representative or ask us. Now I'm going to introduce today's speaker. It's Claes Larsson. He's product manager for screening consumables, and he's leading the development and the technical support for screening media for both aggregate and mining customers. He has been working with engineering and product management with focus on screening related challenges for more than 25 years. And Claes is based in Trelleborg in Sweden. I'm now going to pass over to Claes to begin the presentation.
Thank you, Lotta, for that introduction. I wish you all welcome this morning. Were you finished there, Lotta? Or was it something?
Yes, I'm just, I think that you need to share your screen once more. And presentation mode, and then.
Okay. No?
Okay, good. Yes.
I don't know what happened there. Sorry, guys. No. Okay, thank you for that. Today's presentation will cover some very, let's say, simple technical aspects of screening. And this relates to any industry, really, aggregate mining, recycling, any segment, really. So these challenges will be seen throughout any screening application there is out there in the world. So we have labeled this as 3 ways to improve your screening process with the screen cloths and the screen media. And it will be a couple of examples, a couple of insights around this. So stay tuned for that. Basically, the 3 challenges that we are going to look at today is these 3 that you see on the screen. The first one is pegging. For those of you who are not familiar with it, that is when rocks get stuck in the apertures, in the openings, and they are then unable to leave, and they will sit there in the screen cloth, and eventually, if it's really bad, this can lead to, let's say, total non-performance. And there are various backgrounds and various reasons for pegging, and we will look at this today with a couple of examples to see. The second one is blinding, which is eventually leads to the same effect as pegging, but blinding means fines building up on the screen surface, covering the openings gradually or sometimes even worse, totally, let's say. What is the reason behind that, and what is the background, and so forth. The last topic out of the three is maintenance. Sorry, guys. That is typical things that you see out there that could be fairly simple to correct, but has sometimes a huge impact on the screen cloth lifetime. And let me share those insights with you further on. So when it comes to pegging, let's say I divided this into two sections. When you talk about smaller openings in the screen cloth, and don't get too focused on the actual value here, 30 by 30 millimeter, but in one aspect, let's say below that, let's say as a typical figure. And here we can have a couple of different reasons for that. It could be the screen settings and operating condition, obviously, that can have an effect. The screen cloth is too stiff, it lacks certain flexibility, and that could also increase the pegging of the screen cloth. And the design of the cloth itself, of course. And I will illustrate this with a couple of examples. When we talk about bigger openings, typically way above that limit, and then it's often the case of the rocks cannot pass through the screen media because there are parts, mechanical parts in the way, let's say ledge angles, cross bracing, cross beams, and other, let's say, parts limiting the ability for the rocks to pass through the deck. And that's actually very common. So we will look at a few examples in that area as well. If I begin with this example that you can see here, there's two different types of wire cloth, screen cloths that you can see. If you look on the left-hand side, that's a woven wire cloth. You can see that the wires are interlocking between themselves, and the wires are crimped in a wave pattern. And that cloth is very stiff, and due to that sort of lack of flexibility, the rock can have a tendency to stick in between the wires, like you can see here. Also, another common thing that you can see is that when the screen began to operate at one point in time, you may have had a certain opening and a certain wire diameter that would be suitable for that opening. And then, for example, someone has increased the wire thickness over time, and the thicker the wire gets in relation to the same opening, there will be rock sticking there. And what typically happens is that pegging starts in one location, and then it migrates away from that position, and eventually it can become, like you can see here on the left-hand side picture. If you, on the other hand, go to the right-hand side picture, you can see that the wires are a little bit different. On top of the supports, you have blank areas where the wires are locked, but the wires are just, let's say, transversal wires. They are not interlocked with each other. And these wires can, let's say, vibrate a little bit independently of each other. and thereby that cloth stays more clean. And that's why you see no pegging in that perspective. Other differences between these two cases is also the fact that the left-hand cloth can carry a higher material bed because it's stronger and more stiff, while the one to the right may have limitation in terms of what bed depth you can carry over the deck, and because the wires may eventually, let's say, split apart from each other and release rocks bigger than intended through the deck. So let's continue. Here is another example of a screen where you have a mix, in this case, of rubber cloth and wire cloth doing the same job. And here you can see the screen cloth design as well has an impact in this case. If you look at the area labeled B, where you see this long box, that is to show you that underneath there you have a support in the screen, and the cloth is tensioned above that support, and the support helps to keep the cloth in place. But on a wire cloth, there is no blank area on top of the supports. So typically what you see is that pegging can start where rocks are wedged between the support and the wire. And from that point, it can tend to migrate away from that into the center of the area here. If you compare that to the rubber cloth, where you look at area A, where you can see the area on top of the same support, where the area is blanked out, there is no openings on top of the support, and therefore no pegging in connection with the support. So that's one explanation for the difference that you see here. There is also another difference that can have an effect, that is that the rubber cloth is less stiff. It is more flexible than the woven wire cloth is. So by that slight movement during operation, you also can make sure that there is no pegging of rocks in the screen cloth. So that's a little bit the explanations behind these two cases, why there is a difference, let's say. So leaving the area now where we talked about pegging with smaller openings, now I'd like to address, let's say, pegging with a little bit bigger openings. And there's two pictures here of a similar case. The left-hand picture, you have again woven wire cloth. The opening is probably around, I would say, 50, 60, 70 millimeter-ish in that respect. And if you look at the rock sitting wedged in location A on the left-hand picture, you can see that the rock is a bit elongated, and it is sitting there tight in the aperture because there's no possibility for that rock to pass through because the crossbeam is in the way. The crossbeam is probably located something like 70, 80 millimeter below the screen cloth. And depending on the opening you then have, if there is insufficient room to exit for the rocks, you will have pegging. And what typically will happen on the left-hand side picture is that during continuous operation, pegging will continue from that point and spread from point A out to different areas of the screen. If we look at the right-hand side picture, it's really this similar phenomenon. The rock is pegged in the opening just above the crossbeam. You can see the crossbeam through the apertures of the screen, and this is a rubber cloth. So the phenomenon is exactly similar here. but with a rubber cloth you have a little bit better opportunity to maybe do something. You can blank out the area, you can remanufacture a screen cloth, you can leave blank areas on top of the cross beams, and thereby protecting the cross beams from both wear and pegging, like you can see here. On the sorry, on the left-hand picture with the wires, it's a little bit more difficult. One would think that you perhaps should add a crossbeam lining to at least protect the beam, but to some extent you will have to live with the pegging in the left-hand alternative you see here. The next picture requires some explanations, I would think. If you look at the right-hand side picture, that's the top deck of a scalping screen. Separations or openings are probably in the range of 100 by 100 or 100 by 150 with the flow. The flow goes from the right-hand side of the picture to the left-hand side. So here you see quite a lot of pegging in this case. You can see rocks sticking in almost every aperture here. So what can then be the reason for that? Well, if you go to the left-hand side picture, that is actually a photograph taken from underneath the screen deck. The right-hand side picture is from above the screen deck, and the left-hand side is from underneath. And what you can see here, item A, that's the crossbeam. So, and item B is the bottom of the screen cloth. So if you look at the clearance between the screen cloth and the crossbeam, that's again insufficient for this case. There's a lot of rocks that are, let's say, wedged between the screen panel and the crossbeam. And that's typically how it starts, and then you migrate backwards from there. So in these cases, there is really only one solution to work with if you want to maintain the exact same screen body, and that is to work with the layout of openings and to move them away from these areas and blank out the areas which are in danger, let's say, from this. So the openings on top of the crossbeam should effectively be blank to avoid this phenomenon. So that leaves the section on pegging and different reasons behind that. Blinding, that's the next topic, will be here. And there could be, blinding could of course be depending on opening size. Smaller openings and smaller separations are of course more susceptible to blinding than bigger openings, yes, in general. It's also depending on the humidity of the fines. This happens in dry screening. The higher humidity in fines you have, the bigger problem it is, and also how much fines you have, let's say, in the feed. Also, to address this, there could be various measures to take, thickness reductions and more flexible materials, and also design changes of the screen cloth. So to illustrate this, we will continue with a couple of similar examples, and I will move on now. Here you see two screen decks, and on the left-hand side, for your information, here this is the same aperture layout in every module on this screen deck. And you can see that there is different degree of blinding on these different panels. And this is actually an experiment that was done to see what material would be the optimal for this application to avoid blinding. And also out of interest, in the intersection above the pins between the modules, you can see more blinding. And that is actually because that area is above the support rails in the screen. So that area is firm. There's no flexibility in that area, and that's why you see more blinding above the rails, let's say. But if you look in the aperture area, there are different, let's say, degrees of blinding, as we mentioned. Some panels are completely, let's say, without blinding, and some panels have, let's say, more than half of it blinded. And the difference between these modules that you see in the screen here is different material compounds. And the ones that are more clean, they contain a softer rubber material in this case. Therefore, they are more able to flex during operation, and then the apertures will then stay clean. Well, that sounds fantastic to everyone, but is there any drawbacks with this? Yes, the more flexibility you have in a screen module, the more, let's say, the wear life can be shorter, and also the ability to handle high material bed depths or less, and therefore the membranes then may deflect during operation, and that could of course be a drawback. But the thing is here, it's about to find the right choice for that application in terms of hardness and flexibility and strength in the panel, let's say. But basically, the degree of blinding follows the hardness of the material in the screen module. And the right-hand side picture is really the same. It's different modules, different flexibility in the membranes. So the one you see closest to yourself in the picture that is most clean is more flexible than the ones on the other surrounding it, let's say. So again, another example of the same thing. This is a screen deck that was originally fitted with modules in location A that is actually quite hard polyurethane modules. And these were, when the screen began operation, they were installed, and you can see the blinding building up on the surface here. And subsequently, those modules were gradually changed out for just to of course increase the cut point a bit. As you can see, the openings are not identical, but the modules in the area B, they are more flexible. The membranes can vibrate more during operation, and that's the reason for the difference in blinding you can see here. Well, as mentioned before, that there are certain drawbacks. If everything so far sounds fantastic, we want softer material in the modules to avoid the blinding, and sometimes you also avoid the pegging through this measure. But the increased flexibility also can have a price. If you look at, for example, the left-hand side, location A, here the flexibility when you have a high material load means that you deflect the membranes, you separate the ligaments, and the lifetime will obviously be shorter compared to the other modules before and after that location, let's say. And also, if you look at the picture on the right-hand side, location B along the sidewall, with the broken membranes you see around the apertures makes it more flexible. but on the other hand, the module cannot carry the same load as a standard module, and therefore you have to be careful with that as well, that the membranes may deflect and the screen might not be able to carry the same load as before. So the last section of this short webinar is a couple of, let's say, tips and tricks around maintenance of screen media. And these are quite, let's say, simple measures that are often overlooked. And in quite a few cases, the screen cloths are actually torn apart or destroyed or broken before they're worn out. And this originates in, let's say, various maintenance aspects. But the most common thing is that you can learn a lot of things from scrapped screen cloth, how they broke, where they broke, and what can you read out of that, let's say. Here again, two examples, left-hand side, right-hand side. If I begin with the left-hand side, that's a rubber tension mat, quite big openings on a screen here. And you can see that the cloth is ripped apart in location A. So there's now a big hole, and this cloth cannot be operated any longer and needs to be changed out because you have holes there much bigger than the actual opening in the screen cloth. Well, what's the reason behind that? Well, if you look at the supporting rails under the screen cloth that runs in the screen direction, you can see that they look quite worn. They do not have the original shape, and they are quite affected by something that is not right. And in this case, it is the inability to tension this cloth. This cloth has, let's say, moved against the support and thereby caused a little bit of wear between the support and the cloth. And the reason for that can be several. In this case, it looks like the protective rubber that should have been on the stringers are not there. And so you get a gap between the cloth and the stringers. And during operation, the cloth will then bounce on the stringer, and the cloth will eat up the stringer, and the stringer will be destroyed eventually. And when the stringer is not the correct dimension, there is difficulties. You cannot really tension the cloth again, and this will happen again. So what has happened in location A? Well, it's the wear between the stringer and the cloth has been so deep on the bottom side of the cloth that the textile reinforcement inside the cloth has broken off. That's the reason you see the case in location A. So if you took this cloth out and flipped it upside down, you would be able to see clear wear marks where the stringer has been. So this is the case because there is the, let's say, stringers are worn, so it's impossible to tension the cloth. So to come back, you need to replace the stringers, you need to replace the rubbers and a new cloth, and then make sure that it sits tight to the cloth, and then this will not happen. And if you look at the right-hand side, if you look at location B, you can see that that's probably the location where they're feeding the rocks on the screen. You can see the wires are very thin. If you look to the left of B, and underneath there should have been a crossbeam, but that crossbeam is totally worn off, as you can see. And most likely what happened here, the material that passes through the screen cloth will wear on the crossbeam for sure. But my guess here is that the cloth, the first wire cloth was not replaced in time. A hole came in that location, and the whole feed with the coarse material and everything was hitting the crossbeam directly. There was no cloth in between. So that's the reason this crossbeam is totally gone. Well, again, some other things in the same aspects. If you look on the right hand side, you can see the support under the wire screen cloth, and the support has no rubber, no protective rubber or anything. It's just steel against steel, and with a little bit of movement, you will end up with what you see on the left hand side. And there you can see that the cloth is broken, and you can be 100% sure that the breakage of the cloth in that location exactly matches the location where the stringer is, let's say. So it's movement between the cloth and the stringer, and worn stringers and so forth that causes this. So that's the background behind it. Well, this is just to show that there is more than screen cloth. Screen boxes they also wear, and here you can see a worn out screen body, and the longitudinal supports. You can see how they're worn. The one in the middle looks like almost like a saw blade almost, and the one to the left of it, you can see the top of the stringer is actually quite affected, and this comes from cloth movement against the support, and basically everything that is not tightly matched on the screen will eventually lead to problems like this. So back to the original shape and start all over again. Here's another example. What you can see here on the left hand side is end tension screen mats. It's probably a vibrating feeder or a mobile screen, and you can see that the cloth is destroyed way before the cloth is actually worn out. As you can see, there's plenty of wire thickness left in this cloth. And this comes from the fact that the cloth is not sitting tight to the supports, and therefore there is some movement between the cloth and the supports. And also you can see in the center here that there is still a rubber capping on top of the support in the screen, but at the end it's not there, let's say. So this comes again back to the fact that you need to check tightening, as you see on the right hand picture here with the end tension mat. Is it properly tightened? Is it sitting tight to the supports and so forth? Here's another typical, let's say, maintenance aspect of things. And if you look at the left-hand picture, you can see that the feed chute above is discharging material directly on the end of the first row of panels. So the same panel that is sitting there in the screen, you can see on the right-hand side picture, and the area within the box, that's where the feed chute discharges the feed onto the screen deck. The two rows you can see before that, they are totally unworn. They haven't seen any material whatsoever. And even so, on this screen, for example, there is a 600 millimeter long feed box, and that feed box has even thicker rubber. And the intent here is that of course that the feed to the screen shall hit the feed box. and the feed box will then take care of the impact, and then material will transit across to the screen deck. So by incorrect feed location, there are several drawbacks, and one of them is, of course, that you shorten the lifetime quite drastically of the feed and screen cloths here. Had you fed the feed directly to the feed box, the lifetime will be much longer of this installation. And another aspect is that you lose screen area because there are 2 rows of openings on every panel across the width that you are not using. And it takes longer time for the material to spread across the screen deck and so forth. You are reducing the capacity of your screen by this feed location that you see here. Here's another example of the same thing. What you see here is the feed box, and where the material lays is the first row of panels. And here's again the similar case. The feed is not dropped on the screen in the right location. If the feed had been dropped on the feed box as intended, that lining is much stronger, can take a higher impact, and can handle the load better. The screen cloths are more sensitive in that sense, and that's why you see some bending here, because the lifetime will then be shorter of the installation for the exact same reasons we discussed on the previous page. So here, what to do? Well, the most obvious way would be then to try and steer the feed into the right location, which is the feed box. And if that cannot be done, there are also ways of changing the feed end. You may use blank panels, more heavy-duty panels in the feed end and things like that. That possibility, of course, also exists. The last picture here is from a screen which takes a heavy impact. It can be anything, any application with big feed lumps and things like that. So what you can see in the boxed area, that's the feed end of the screen. Those 3 rows of panels are actually of a more thick, a more heavy-duty design compared to the rest of the screen that you see further down. And that is to handle the bigger material flow, the bigger abrasion, anything that comes with a feed that goes quickly down to the screen, like you can see here. And that is also a way of prolonging the wear life of the screen deck without putting in too much blank area to reduce the capacity. You can have different setups in the feed end and in the remaining section of the screen to balance the life of the screen. So, some key takeaways of this presentation here. Basically, what we say, anything that is not properly tensioned and has an ability or room to move against each other, eventually you will have problems such as prematurely broken cloths and things like that. Pegging and blinding can be reduced by changing the screen cloth design, by different layout of openings, or by more flexible media options. And feed discharging in the wrong location leads to poor life of the screen and can easily be adjusted and can increase the life of your screen deck quite rapidly. So,
okay.
We are
Thank you,
down
Claes.
to the question. Thank you.
Yes, thank you. I hope that everyone was able to learn a thing or two. And it's now time for our question and answer session. And Claes, he will try to answer the questions that you have entered into the question box. So if you have anything else you want to answer, please enter your question into the question box. If we do not have time to answer it right away, we will we will do it by email afterwards. But let's start. Claes, when maybe you want to put your web camera on so we can see you if you want. Then when is a good time to use polyurethane and when it's a good time to use rubber media?
Well, that's a very common question, I would say. The trend has typically been that in installations where you use water, where you add water, spray water, that has been more predominant to use polyurethane in those areas, and dry screening has always been more rubber application. So that's one way to look at it. It's not, let's say, black and white. Then, of course, rubber is more suitable for screening of as the lump size becomes bigger. When you have more primary screens, you get more of a shock absorption and things like that. So rubber is more predominant in the coarser screening side of things. And thereafter, you could say there are certain trends. Certain markets are more polyurethane than other markets, let's say, but polyurethane is also prevailing in the areas where you have really small apertures. It has always been more easier to make small, really small apertures in polyurethane. So that, like say, dewatering, drainage, and things like that is typical polyurethane applications. So okay. That's a short, let's say, idea behind that.
Yeah, good. What is the best media or screen cloth for river bed material?
Well, I assume we talk about riverbed gravel here, and if it's a dry process, then rubber can be applied, but it's typically a process where you use water to spray and wash. So that's typical polyurethane applications, except for the more coarser separations, I would say.
Okay, we have one about wear life. How do the life of polyurethane and rubber compare in terms of screen life?
Well, often you're going to have to look at exact individual applications, but as a general comment, I would say that if you go on the coarser side, the really coarse materials handle big separations and things like that. There, I would say that rubber is much better, performs much better than polyurethane. When it comes to other areas, it's very individual, let's say. So it's very difficult to answer that directly. It depends, let's say.
Okay, we just need to contact you with more information.
Yeah.
Okay. How do I know if the cloth is properly tensioned?
Well, if we look at the tension mats we showed in the examples here in the presentation, if you tension a screen cloth, and for example in rubber, and when you then on the screen check it afterwards, you should be able to lift the cloth from the support, but when you drop it again, there should be no space between the support and the screen cloth. Let's say that's how you shake it. And if there is a distance between the support and the screen cloth, then it can flap and vibrate between the support and the cloth and cause damages, let's say.
Okay, I think that's it. At this time, we're going to close the webinar. Thank you all for taking the time and join us to learn more about screening media's role in the screening process.
Thank you.
Thank you. If you change slide, I would just say some final things. Just want to mention that if you enjoyed this session, You can also join on July the 21st when one of our other screening solution experts, Ricardo Gawa, will look at the screening process as a whole and offer 6 tips for more efficient screening. And some last reminder, the webinar, it's been recorded and it will be sent to you by email. So please look for that. At the same time, we will also answer all the questions that we didn't have time to answer right now. If you do have a question after the webinar that you didn't have time to ask, you can always ask us by email. You can either use the mining.webinars@metso.com email or aggregateswebinars@metso.com. And you are also welcome to visit our website, metso.com/screenymedia for more information. And now, before we close, I want to inform you that when we do close the webinar, you will get a short 3-question survey. It will appear on your screen. It's not required, but if you have a moment, we would really appreciate your feedback. So thank you all again. I really hope that you have a good day. Thank you.